Hello all, welcome to a new video of Friends Corner channel. In this video we are discussing about formula for divisibility test. We all know how to check whether a number is divisible by a composite number. It's too easy. But when it comes to prime numbers, there is some sort of difficulty. So in this video we are discussing about formula for divisibility test, especially for prime numbers between 1 and 50. We can start from the number 2. So, if A, B, C, D, E, F is a 6-digit number, we have to check whether this number is divisible by 2 or not. So, consider this last digit F. The rule is, if F is even, then this number is divisible by 2. Select the last digit. Check whether it is even or odd. If it is even, then this whole number is divisible by 2. For example, we have to check whether 3112 is divisible by 2 or not. The last digit is 2. 2 is even. So 3112 is divisible by 2. Next prime number 3. We have to check whether this number is divisible by 3 or not. So the rule is, if the sum of the digits of this number, that is A plus B plus C plus D plus E plus F, is a number, the sum is a number which is divisible by 3, then this 6-digit number will be divisible by 3. For an example, 396. In this number, we have to check whether this number is divisible by 3 or not. The sum of the digits of the number will be 18. 3 plus 9 plus 6 is equal to 18. We all know that 18 is a multiple of 3, or 18 is divisible by 3. So 396 will be divisible by 3. Got it? Then the next prime number is 5. In the case of 5, it is simple. We have to check whether this number is divisible by 5 or not. Select the last number. Select the last digit F. If F is 0 or 5. If F is 0 or 5, then this number will be divisible by 5. For example, 105 is a number, it's a 3-digit number. We have to check whether this number is divisible by 5 or not. So the last digit is 5. So it is clear that this whole number will be divisible by 5. Then the next prime number is 7. In the case of 7, we have to check whether this number is divisible by 7. If the rule is, if A, B, C, D, E minus 2 multiplied by F, we will get a number here. Check whether this number is divisible by 7 or not. If it is divisible by 7, then this number is divisible by 7. You have to continue this rule again and again to the answer. Don't overthink about it. Example, that is 9464 is our number. We have to check whether this number is divisible by 7 or not. In the case of this number, apply the rule. 946, the last digit is 4 and the rest of the digit will make a 3-digit number, 946. So 946 minus 2 into last digit is 4. So this will be 938. Apply the rule here. So 938 will be 93 minus 2 into 18. It will become 77. We all know that 77 is divisible by 7. So 9464 will also be divisible by 7. All clear? Yes. Our next prime number is 11. We have to check whether this number is divisible by 11 or not. So first we have to consider the sum of all odd place digits in this number. That means B plus D plus F. then this sum minus sum of all even place digits a plus e plus e. So there is an answer for this. This answer is 0 or a number divisible by 11. Then this whole number is divisible by 11. That is the rule here. For example, 2563 is a number. We have to check whether this number is divisible by 11 or not. So the sum of all odd place digits are 5 plus 3 minus sum of even place digit means 2 plus 6. This answer will be 0. That is 8 minus 8 will be 0. So 2563 is divisible by 11. For another example, 7392. In this case, you have to find 3 plus 2 minus 7 plus 9. So this answer will be minus 11. 5 minus 16, it is minus 11. So minus 11 is a number which is divisible by 11. 1392 will be divisible by 11. In the case of 13, we have to check whether this number is divisible by 13 or not. So the rule here is if A, B, C, D plus 4 into last digit is a number which is divisible by 13, then this whole number will be divisible by 13. For an example, we have to check whether this number is divisible by 13 or not. As we proceed, we have to find the last digit, it is 3. The rest of the digit will make a 4-digit number, and we have to add this 4-digit number to the number 4 into 3. So we will get an answer 1339. Applying this rule again in this number, 133 plus 4 into 9 will become 169. 16 plus 4 into 9 will become 52. We all know that 52 is divisible by 13. So this number 13,273 is also divisible by 13. Our next prime number is 17. In this case, we have to find whether this number is divisible by 17 or not. So the rule here is same like this. We have to select the last digit of this number, that means it is F, and we have to subtract 5 into F from this number. If the answer is a number which is divisible by 17, then this whole number will be divisible by 17. So we can do an example. 7544 is a number, and we have to check whether this number is divisible by 17 or not. Applying the rule, 1754 minus 5 into last digit is 4. 5 into 4 will be 1734. And applying this rule again in this number, 173 minus 5 into 4, that is 153. 153, 15 minus 5 into 3. We all know that 5 into 3 is 15, so 15 minus 15 is 0. 0 is divisible by 17, so 17,544 is divisible by 17. This is the way of finding whether a number is divisible by 13, 17, 19, then 23. Like this, the last digit is multiplied by a number. Here it is 4, here it is -5, and in the case of 23, number in this place will be 7. As I said, in the case of 23, the rule is A, B, C, D, E plus 7F. If this number is divisible by 23, then this whole number A, B, C, D, E, F will be divisible by 23. In the case of 29, the next prime number is 29. A, B, C, D, E plus 3F is a number which is divisible by 29. Then this whole number will be divisible by 29. Like this, there is only change in the number in this place. Maybe it is a positive number or a negative number. As we proceed, the next prime number will be 31. In the case of 31, this number will be -3. The next prime number is 37. The number in this place will be -11. In the case of 41, the number will be -4. 43, the number will be 13. The last prime number before 50 is 47. In the case of 47, the number in this place will be -14. I hope you all get this idea about the divisibility test, especially for prime numbers between 1 and 50. Through continuous practice, we will be good at doing this. Okay.